Today we're covering environmental economics and policy. This is where decisions about things like pollution, resources, and technology are evaluated, and it involves trade offs, costs, benefits, and values. So, all of these things are taken into account when making decisions about our economics and policy. And they can be used by our policymakers, whether they're state, city, county, federal. They can also be made by corporations or even individuals with businesses. In this chapter, we'll cover the historic development of environmental protection, look at who participates in environmental decision making, and how technology and innovation support sustainability. We'll also evaluate the cost and benefits of trade and explain how environmental economics helps society make choices when natural resources are limited. When we talk about environmental protection, it's easy to think of it as a modern idea, but people have been thinking about protecting natural resources for thousands of years. This timeline shows that environmental protection didn't suddenly begin in the 20th century. It developed as societies recognized limits on resources and the consequences of pollution. Starting as far back as 2700 BCE in the city of Ur in Mesopotamia, located in what's now southern Iraq, they passed laws to protect remaining forests. Wood was very important for these communities. They used it for fuel, building, tools, but overuse led to deforestation. Protecting forests helped prevent the soil erosion, reduced flooding, and ensure that long term access to vital resources was guaranteed. This is one of the earliest examples of sustainability. By 80 BCE, the Roman Senate took action to protect water reserves used for sanitation. Clean water was connected to public health, and the Romans understood that contaminated water led to disease. Protecting water resources benefited both human populations and surrounding ecosystems by limiting waste dumping and maintaining freshwater quality. Fast forward to the early colonial United States, figures like Benjamin Franklin advocated for laws defending public rights against industrial pollution. Even before large scale industrialization, people recognized that unchecked pollution harmed shared resources like air and water. This laid the groundwork for the idea that environmental protection is also about protecting the public good. In the early 1900s, scientist Alice Hamilton pushed for regulations of industrial toxins, including lead and radioactive materials. Her work highlighted the link between environmental exposure and human health. Reducing toxic pollution not only protected workers, but also prevented long term contamination of soil and water systems. In 1906, the Antiquities Act gave U.S. presidents the authority to establish national monuments. This created a major shift because now we're recognizing that landscapes, ecosystems, and cultural sites were worth protecting before they were damaged or destroyed. So, preserving these areas protects biodiversity, habitats, and natural processes we still depend on today. Finally, in 1960, Rachel Carson's work helped expose the environmental and health impacts of pesticides like DDT. Her research sparked modern environmental regulations by showing how chemicals moved through ecosystems and accumulated in wildlife. This led to regulations that improved water quality, protected species, and reduced human exposure to harmful substances. Here we have some key laws that shaped modern environmental protection in the United States. Most of these developments happened around the 1970s, which is why that era is often called the beginning of the modern environmental policy movement. First, we have the National Environmental Policy Act, which is also referred to as NEPA. NEPA was one of the first major environmental laws in the US. It required federal agencies to evaluate how major projects like highways, dams, or pipelines might impact the environment before they get approved. A big part of NEPA is the environmental impact statement, or the EIS. This forces decision makers to consider things like pollution, habitat loss, and the effects on the community before damage happens. NEPA benefits the environment by promoting prevention rather than cleanup. And it also encourages public involvement, giving citizens a voice in a larger environmental decision. Next, we have the Environmental Protection Act. This was, again, in 1970. It was created not as a law, it's a federal agency, and they're responsible for enforcing environmental laws. The EPA sets pollution standards, monitors air and water quality, and enforces laws like the Clean Air Act and the Clean Water Act. One of the biggest environmental benefits of the EPA is that it holds accountability. It can fine or penalize industries that violate these laws and help reduce pollution and protect public health. Finally, we have CITES, which occurred in 1973. This is the Convention on International Trade in Endangered Species. Finally, in 1973, we had the Convention on International Trade in Endangered Species, or CITES. Unlike NEPA or the EPA, this is a global agreement involving more than 180 countries. CITES regulates or bans the international trade of endangered plants and animals. These are things like ivory, exotic pets, and rare plants. This protects species from being driven towards extinction by global markets, and it helps maintain biodiversity, which is essential for stable ecosystems. So we talked about some milestone acts and organizations. Now we're going to go a little deeper into some of these laws. We'll start with the Clean Air Act, first passed in 1970. It's been updated several times since. This law set national limits on air pollution, like sulfur dioxide and lead. The environmental benefit here is huge. By limiting emissions, the Clean Air Act reduces smog, acid rain, and health problems like asthma. It also showed that air pollution doesn't stop at cities or states or borders, so national standards were necessary. Next is the Clean Water Act, passed in 1972. This law regulates what can be discharged into rivers, lakes, and other navigable waters. It includes strong protection for wetlands. This law helps reverse decades of water pollution. It improved drinking water sources, protected aquatic ecosystems, and restored many waterways that were once considered biologically dead. The Safe Drinking Water Act focuses specifically on water we drink. It requires testing and treatment standards for public water systems and protects underground water sources. This law benefits the environment by reducing chemical contamination of groundwater and ensuring that access to clean drinking water is treated as a public health priority. In 1976, two major laws were passed. The Toxic Substance Control Act gave the EPA authority to test and regulate chemicals before they became widespread. At the same time, the Resource Conservation and Recovery Act created a cradle-to-grave system for managing hazardous waste. So what I mean by cradle-to-grave is from the start of a product being made to the time when it has finally ended its use. So from the time that it's made to the time that we dispose of it or get rid of it. Together, these laws reduced long-term environmental contamination by controlling how chemicals and waste are produced, used, stored, and disposed of. By 1980, it became clear that past pollution had already caused serious damage. That's where the Comprehensive Environmental Response, Compensation, and Liability Act, also known as the Superfund, comes in. This allows the federal government to clean up contaminated sites and hold polluters financially responsible. It benefits the environment by restoring polluted land and preventing toxic substances from continuing to spread through soil and water. Finally, the Food Security Act. This occurred between 1985 and 1990. It included reforms that encouraged farmers to protect environmentally sensitive land, especially wetlands and erosion prone areas. This law connects agriculture to the environmental protection by promoting soil conservation, water quality protection, and long term sustainability of farmland. Up to this point, we've talked about environmental laws and agencies. But having law doesn't automatically mean it's effective. So we're going to look at some of the main challenges enforcing environmental regulations. One major challenge is insufficient funding from Congress. Agencies like the EPA can only enforce laws if they have enough staff, equipment, and resources. When funding is limited, inspections happen less often, and enforcement slows down. And some violations may never even get addressed. Another issue is administrative delays and layers of bureaucracy. Environmental cases often require extensive paperwork, multiple reviews, and coordination across offices. While these processes exist to ensure fairness and accuracy, they can also slow enforcement and delay environmental protection. Enforcement can also be complicated by unclear jurisdiction. Sometimes it's not obvious whether a problem falls under federal, state, or local authority, or which agency is responsible. This can result in confusion, overlap, or situations where nobody acts quickly. Finally, political interference can affect how strictly environmental laws are enforced. Changes in political leadership, shifting priorities, or pressure from industries can lead to weaker enforcement or delays, even when laws are still on the books. These challenges don't mean environmental laws are useless, but they help explain why enforcement is often uneven. Effective environmental protection depends on not just a good law, but on funding, clear authority, and consistent enforcement. So far, we've talked mostly about federal laws, but it's important to remember that states can also play major roles. California is one of the best examples of state level leadership in environmental protection. California began regulating environmental quality earlier than most states. In the 1950s, it established the country's first air quality program. This was largely in response to several smog problems, especially in Los Angeles. By acting early, California showed that environmental regulations could improve public health while still supporting economic activity. California's leadership continued with its 1988 Clean Air Act. This introduced stricter air pollution controls than existed at a federal level. These standards were so effective that they helped influence federal Clean Air Act amendments in the 1990s. This is a great example of how state innovation can shape national policy. California also moved faster than the federal government on vehicle emission standards and controls of toxic air pollution. Because California has such a large population and automobile market, its stricter standards pushed automakers to develop cleaner technologies, benefiting air quality both in California and eventually across the country. In 1970, California passed the Port of Cologne Water Quality Control Act, which regulates water pollution at the state level. This law became the model for the Federal Clean Water Act, showing again how state policy can lead the way. It helped protect rivers, lakes, groundwater, and coastal waters from pollution before federal rules were fully developed. California's case shows that environmental protection doesn't always flow from the government down to the states. Testing new ideas can later become national policies. So, this is one of the reasons why advocating at state levels is very important because it can expand throughout the entire country. One state sets a good example, the rest can follow. But change doesn't happen just at a federal or state level. We can have international levels where countries work together to address environmental problems that don't stop at borders. Many international environmental efforts are coordinated through organizations like the United Nations and World Bank, but international agreements come with challenges. Countries are sovereign, meaning they choose whether and how strictly to enforce agreements and enforce it. That can often be weaker than at the national level. A major success was in 1986 with the whaling moratorium, which dramatically reduced commercial whaling worldwide. This helped the prevention of the extinction of several whale species and showed that international agreements can protect wildlife when there is broad cooperation. In 1991, countries agreed to ban ocean dumping of many types of waste. This reduced marine pollution, protected oceans, and showed growing recognition that oceans are shared resources. The Antarctic Treaty in 1991 is another strong example. It prohibits mining, limits pollution, and protects wildlife on an entire continent. Antarctica is one of the few places on Earth protected primarily for science and environmental preservation, showing that international cooperation can achieve a lot of progress. The Montreal Protocol is often considered the most successful international environmental treaty. It phased out ozone depleting substances like CFCs, which led to the recovery of the ozone layer. This treaty worked well because it had clear goals, strong scientific backing, and widespread participation. CITES, which we've seen before, regulates the international trade of endangered species. By limiting or banning trade in things like ivory, exotic animals, it helps protect biodiversity from the global market pressures. The Rotterdam Convention in 1998 requires countries to give informed consent before certain hazardous chemicals can be traded internationally. This improves transparency and helps protect countries, especially developing ones, from receiving dangerous substances without full knowledge of the risk. The Cleaner Production Declaration in 1998 encouraged countries and industries to reduce waste and pollution at the source rather than relying on cleanup after the fact. This shows a shift towards prevention and more sustainable industrial practices. Finally, the UN Framework Convention on Climate Change and the Kyoto Protocol looked at limiting greenhouse gases. These agreements were important steps because they highlight the challenges of international action. Commitments varied drastically between countries, so enforcement was limited, and results have been a little bit mixed since those protocols and frameworks were put in place. So these international agreements definitely have their challenges. They're not always as productive as we hope they would be, but sometimes they can shift even a handful of countries in the right direction. So now that we've talked about all of these laws and policies and frameworks, we're going to talk about main stakeholders that are involved in environmental decision making and how each plays a different role. Understanding these groups helps explain why environmental policies can be complex and sometimes controversial. First, we have government agencies such as the EPA, local planning boards, and international bodies. These groups are responsible for creating, enforcing, and regulating environmental laws. They set standards for air, water, and land use, and they often are the ones monitoring compliance and issuing penalties when rules are broken. Next, we have industry and businesses. These groups are major users of natural resources and, in many cases, major sources of pollution. At the same time, businesses can also drive green innovation. Things like cleaner energy, fuel efficient vehicles, and sustainable materials often come from industry responding to regulations, market demands, or both. We also have nonprofits and non governmental organizations, or NGOs. These are groups like the Sierra Club, the World Wildlife Foundation, and Greenpeace. These organizations advocate for environmental protection, educate the public, and often act as a watchdog. They help raise awareness, influence policy, and hold governments and industries accountable. Scientists and academics play a crucial role by providing the data and research behind environmental decisions. They study ecosystems, model environmental impacts, and assess risks. While they don't usually make policies directly, their research helps guide laws, regulations, and management strategies. Finally, we have the common citizen and communities. These are the people most directly affected by environmental decisions. Citizens influence policy through voting, public comments, community action, and public pressure. Local voices often play a key role in shaping decisions about land use, water quality, and environmental justice. Environmental decision making is really a shared process. Each stakeholder brings different priorities, power, and perspective. So, understanding these roles can help explain why solving environmental problems often requires a lot of cooperation and why solutions can take time. Environmental problems can feel overwhelming, but this slide shows something important. Technology plays a growing role in helping address environmental challenges. Green technologies are advancing quickly, and many of them either reduce environmental harm, lower the costs, or both. Instead of choosing between the environment and economic growth, these technologies can help us do both. First is clean energy, which includes solar, wind, and geothermal, and advanced battery storage. These technologies reduce reliance on fossil fuels, which lower greenhouse gas emissions and air pollution. Energy storage is especially important because it makes renewable energy more reliable even when the sun isn't shining or the wind isn't blowing. Next is smart agriculture. Technologies like precision irrigation, drones, aircraft intelligence helps farmers use water, fertilizer, and pesticides more effectively and more efficiently. By applying resources only where they're needed, smart agriculture reduces water waste, limits runoff into rivers and lakes, and increases food production while lowering the environmental impact. Another area is green building design. It includes passive design strategies, energy efficient construction materials, and certifications like LEED. Green buildings use less energy and water, they reduce emissions, and often improve indoor environmental quality. Since buildings are a major source of energy use, these improvements can make a significant environmental impact. Finally, there's carbon capture and storage, or CCS. This technology captures carbon dioxide emissions before they enter the atmosphere and stores them underground. While it's not a complete solution on its own, CCS can help reduce emissions from industries that are difficult to decarbonize, like cement and steel productions. Overall, technology is not the magical solution that we hope for, but it is a very powerful tool. And when we combine the effective policies and informed decision making, technological advances can help reduce pollution. They can conserve resources and they can make our futures more sustainable. And that's always a positive step. So, who actually drives US green energy innovation? When we talk about green energy innovation, it's easy to think it comes from just one place. But in reality, it's driven by several key players working together. This slide breaks down who actually pushes clean energy forward in the United States. The Department of Energy is a major player in the world of federal level. With the DOE, the Office of Energy Efficiency and Renewable Energy invests in technology like wind, solar, geothermal, hydrogen, and energy efficiency. These investments help reduce cost, improve performance, and move new technology out of the lab and into the real world. We also have ARPA-E. This is another DOE program. It stands for Advanced Research Project Agency Energy. It's modeled after DARPA, which focused on high risk, high reward ideas. These are projects that are too early or too uncertain for private investments, but could be game changers if they succeed, like new battery chemistries or next generation grid technologies. The US also has a network of national laboratories, including places like NREL, Lawrence Berkeley, and Oak Ridge. These labs are research hubs. They conduct large scale experiments, test new technologies, and provide scientific data that supports both private and government decision making. Now, the private sector is where those research technologies are scaled and commercialized. Companies like First Solar, Tesla, GE, and NextEra Energy drive innovation in areas like electric vehicles, batteries, solar panels, and power grids. Businesses often move ideas from research into products people actually use. Finally, universities and research institutes play a very important role. Top research universities conduct fundamental research and develop breakthroughs in energy storage, smart grids, and carbon capturing. They also train engineers, scientists, and policymakers who continue innovation in every other sector. So, the key takeaway here is that energy innovation isn't driven by one group alone. It happens when government funding, academic research, and private industry work together. This chart shows how different countries and regions approach green energy innovation. So each one has strengths and weaknesses. There's no perfect model, but we're going to walk through a couple of examples. The United States uses what's called a market driven approach, supported by strategic public investments. So agencies like ARPA-E and recent policy decisions like the Inflation Reduction Act fund the research, offer tax incentives, and support innovation in clean energy, such as batteries, carbon capture, and storage. From there, entrepreneurial energy and advanced technology, especially those driven by venture capital, kind of push this system. The main weakness is that policy can be a bit fragmented and it can slow down when political priorities shift. So sometimes if the funding is there, if the people that are making the policies decide that they want to invest in green energy, there's sufficient funding. But if those policymakers change and the new ones coming in decide that they don't want to invest in green energy, they want to invest in fossil fuels, that changes. So it's very volatile, and there's not a long term guarantee for this. China's system is a little more state led and centralized. The government uses a 5-year plan. State owned enterprises and large subsidies are rapidly scaled up for technologies like solar, wind, electric vehicles, and power grids. The strength here is speed and manufacturing dominance. The weakness, higher financial risk, less transparency, and more limited private sector innovation. So they're looking at a 5-year plan, they're investing in certain industries, and those industries may provide good results, they might provide bad results. So it's sort of a gamble. Germany follows a public to private policy driven model. It's often referred to as energy transition. It relies on tools like feed-in tariffs, public investment banks, and national R&D funding to promote wind, solar, hydrogen, and energy efficiency. The strength of this is that it has very high public support and very close cooperation between the government, industry, and academia. The challenge, though, is it does involve high costs. There's also some grid constraints, and it has delays in phasing out coal. So these kind of work together to work against the system, but it has been very promising, and they do have a lot of public support. So while it may take a little while and it may take a lot of money, they're working towards that goal, and it doesn't seem to be quite as volatile. The European Union takes an integrated approach across many different countries. Programs like Horizon Europe, the Innovation Fund, and carbon pricing through the emissions trading system focus on things like climate tech, hydrogen, renewables, and circular economies. This gives the EU very strong coordinated climate policy, but the decision making can be slow because it requires agreement across many nations and bureaucratic systems. So if not everyone's on the same page, you don't get a lot of progress. Japan's approach is government coordinated with strong corporate leadership. Agencies like METI, along with tools like green innovation funds and feed in tariffs, focus on hydrogen, nuclear energy, batteries, and smart grids. Japan Japan is very well known for its efficiency in industrial research, but public resistance to nuclear energy and limited land for renewables kind of presents a challenge. So it does have a lot of positive aspects to it, but at the same time, if the public is not on board, there's going to be problems. Policy tools are the ways that government encourages innovation rather than trying to invent things themselves. Instead of telling companies exactly what to build, these tools shape incentives in markets. First are subsidies and grants. These are direct investments from the government into research and development, especially clean technology. Grants help fund early stage ideas that might be too risky or expensive for private companies to support on their own. So this reduces the financial risk and allows innovation to happen faster. Next are tax incentives. These includes tax credits for renewable energy projects or for making energy efficient upgrades. Tax incentives encourage businesses and homeowners to invest in cleaner technology by making them more affordable. Instead of forcing change, they make clear choices financially attractive. Another tool is carbon pricing, which puts a cost on pollution. When greenhouse gases become expensive, companies have a strong incentive to innovate, whether that's improving efficiency, switching fuel types, or developing new technology. Carbon pricing doesn't dictate the solution, it lets the companies decide for themselves what they do. In some cases, a company might switch and make those changes, but in other cases, they might just pay the cost and then transfer that cost onto their customers. Finally, there are regulations such as fuel economy standards and emission limits. While regulations often are seen as restrictive, they can drive innovation. When standards are set, companies invest in cleaner and more efficient technology to meet those needs, often leading to better products overall. Innovation doesn't happen in isolation. Policies like grants, tax credits, carbon pricing, and regulations create conditions that can make innovation possible. So when policy and technology work together, environmental progress becomes faster and more durable. Trade plays a major role in environmental outcomes. It's not necessarily good or bad, but we're going to look at some of the benefits and cost of international trade. One benefit is the trade in technology and innovation transfer. International trade allows countries to improve cleaner and more efficient technology like renewable energy systems, energy efficient equipment, or modern agricultural tools. So it can improve energy use and make progress more sustainable, especially in developing regions. Trade also encourages specialization. Countries focus on producing goods they can make most efficiently. When done responsibly, this can reduce overall resource waste and lower environmental degradation by avoiding inefficient production methods. Trade also increases access to green products. While we may not make these products locally, we can use them to reduce energy, whether it's in our house or businesses. For example, a particular type of tint that goes on your windows may be produced in another country, but that can help reduce the heat that goes into your house and reduce your energy bill because you're not running the air conditioning as much. You might have new light bulbs or solar panels that are produced in other countries. China's been a major producer in solar panels and solar technology, and they've drastically reduced the cost over the years. So that's one example how here in the United States we actually can benefit from that by using trade. Some trade agreements can include environmental standards. These can require the participating countries to enforce environmental laws and protect wildlife and combat illegal activities like unsustainable logging or wildlife trafficking. Therefore, trade agreements can become tools for environmental accountability. Trade also helps scale environmental markets, such as carbon credits, renewable energy components, and ecotourism. When environmental protection becomes an economical value, it encourages conservation by tying environmental health and economic return. So, those were some benefits. Now we're going to look at the cost of trade. One major concern is the pollution haven effect. Companies move pollution heavy industries to countries where they have weaker environmental regulations. This doesn't reduce global pollution, it just shifts environmental damage to somewhere else. Trade can also increase resource extraction. Global demands for products can drive deforestation, overfishing, and mining, especially in developing regions where ecosystems may be damaged faster than they can recover. Another cost is carbon emissions from transportation. Shipping, trucking, and aviation all contribute significantly to greenhouse gas emissions. Global supply chains increase the climate footprint of goods, even if the products themselves are efficient. Cheaper imports can sometimes undermine local products. If sustainable products cost more locally, they can become outcompeted by cheaper, less environmentally responsible imports. And this can discourage sustainable practices at the local level. Finally, there's illegal and unregulated trade. Activities like wildlife trafficking, illegal logging, and hazardous waste dumping often exploit weak enforcement, and this undermines environmental protections and harms ecosystems. Environmental economics is about how society makes choices when natural resources are limited. Traditional economics focuses on prices, markets, and profits. Environmental economics expands that view by recognizing that the environment has value, even when it isn't bought or sold in a market. Environmental economics defines economic efficiency as getting the greatest value benefit for society. That means looking at the total benefit of an activity and subtracting the total cost of producing it. So the goal isn't just profit, it's overall well being. What makes environmental economics different is that it expands the usual economic picture. On the benefit side, it adds the value of the environment. Things like wildlife, clean air, clean water, and ecosystem services such as flood protection and pollination. On the cost side, it includes harm from pollution, health impacts, environmental damage, and long term resource depletion, costs that are often ignored in standard markets. It also thinks in terms of marginal cost and marginal benefits. Efficiency happens at a point where the additional benefits of an action equals the additional cost. For example, reducing pollution makes sense up to the point where the cost of further reduction equals the added benefit to society. So, what we want to look at here is that environmental economics helps us make better decisions by accounting for both economic and environmental impacts. It's a framework for evaluating policies like pollution control, conservation efforts, and climate solutions. By asking not just what does this cost, but also who benefits, who is harmed, and by how much, we can answer the decisions for making policies. In a perfect market, buyers and sellers interact in a way that leads to the most efficient outcome for society. Businesses try and keep their costs low, and consumers make choices based on how much value they get from that product. In this ideal situation, the cost to society of producing the last unit of good, what economists call the marginal cost, is exactly equal to the benefit that the consumer gets from that unit, known as the marginal benefit. When these two values are equal, like we can see in this graph, resources are not wasted. Production levels are efficient, and overall societal welfare is maximized. But real markets rarely work this smoothly, especially when natural resources are involved. Many environmental resources are scarce, meaning they're limited and can't be produced easily or replaced. When markets fail to account for this scarcity, we end up with an outcome that is ineffective and inefficient. One result of this failure is something called deadweight loss, which represents benefits to society that are lost because too much or too little of a good is produced, or because environmental damage is completely ignored. One of the main reasons markets fail in environmental context is due to externalities. An externality occurs when a cost or benefit of any activity affects people who are not directly involved in the decisions. For example, pollution is a negative externality because the health and environmental costs are experienced by the public, not just the producer. On the other hand, activities like planting trees can create positive externalities because they improve air quality and provide benefits beyond the person who planted them. Because these costs and benefits fall on third parties, they're often left out of the market price. This means products may appear cheaper than they truly are when environmental damage is considered, leading to overproduction and increased pollution. These are some examples of positive and negative externalities. A positive externality is one where the benefit is not borne by the person conducting the act. This could include the use of rain barrels to reduce stormwater runoff, or using cover crops to improve soil and water quality. Negative externalities are the cost of the action not borne by the producer, only by society. So this would be something like automobile emissions harming public health, yet producers don't account for that cleanup. This chart shows how cost-benefit analysis is used to evaluate climate and environmental policies. starting with future emissions and ending with the decisions about whether a project is worth doing. At the top of the chart, we begin with future emissions. This represents how much pollution, such as carbon dioxide, we expect to release over time if no action is taken. These future emissions are important because they drive long-term changes in climate. Those future emissions lead to the next step, which is the estimated cost of climate damage. This includes things like damage from stronger storms, sea level rise, heat-related health impacts, and ecosystem loss. These costs often occur years or decades into the future, which makes them harder to compare to the costs we pay today. The chart then splits into two paths based on something called the social discount rate. The discount rate reflects how much we value future costs and benefits compared to present day ones. On the left side of the chart, we see high social discount rates. This means future damages are valued much less than current ones. When we discount the future heavily, climate damage appears smaller in today's terms. As a result, the social cost of carbon, the estimated damage caused by emitting one additional unit of carbon, is calculated to be low. When the social cost of carbon is low, climate projects often appear too expensive. So the chart shows that project costs outweigh the benefits. On the right side of the chart, the outcomes change because the assumption changes. Here we use low social discount rate, which means we place greater value on future generations in long-term environmental damage. When future harms are taken seriously, the estimated damage from the emissions are much higher. This leads to a higher social cost of carbon, meaning each unit of pollution is considered more harmful. Under these assumptions, the same climate project now looks worthwhile because the project's benefit outweighs the cost. Under these assumptions, the same climate project now looks worthwhile because the project benefits outweigh the cost. Now, some environmental resources don't fit neatly into market systems. Public goods such as clean air are non-excludable and non-rival, meaning people can't be prevented from using them, and one person's use does not reduce the availability for others. This leads to the free ride problem, where individuals benefit without paying, causing markets to underprovide these goods. Common pool resources such as fisheries or forests are non-excludable, but rival. Anyone can access them, but overuse by one person reduces availability for others. This can lead to the tragedy of the commons we mentioned at the beginning of the semester. And resources are depleted because no single user has an incentive to conserve them. When evaluating environmental policy, economists look at several criteria. Efficiency focuses on maximizing total societal benefit by balancing cost and benefit. Cost effectiveness asks whether a policy achieves its goal at the lowest possible cost. Policymakers also consider whether policies encourage innovation, such as developing cleaner technology. Finally, equity and fairness matter because environmental policy often affects communities differently, raising ethical and political concerns. Finally, it's important to recognize that traditional economic measures like GDP don't capture overall well-being. GDP measures production, but it doesn't account for environmental quality, health, or education. Alternative measures such as the Human Development Index, the Genuine Progress Index, and the Environmental Performance Index attempt to provide a more complete picture of society's well-being by including environmental and social factors.